Hi children, in this class we will discuss making chemical equations more informative. Okay, if we have more and more information regarding chemical equations, we can identify whether it is a solid, liquid, gas, or aqueous. Okay, and we can give the exact product related to that. Because if you know exact notations of these, okay, you can identify whether it is a precipitate or liquid or gas easily. So today in our classes we will discuss about chemical equations more informative. Okay, so here 10th class chapter 2 we are in day 4 now. In the day 4 we are going to discuss about chemical equations more informative. Okay, see here totally by using physical state and by the heat exchanges, by the gas evolved and precipitation formed, and sometimes using catalysts. Okay, by using these data we can identify easily. Okay, so in this we will discuss one by one briefly, okay, with examples. Here in this case physical state. Here there is a number of equations or the chemical equations. Okay, whether it is solid or liquid doesn't know. Okay, if you wanted to give more and more interpretation regarding chemical equations, we need to know whether it is a solid substance or liquid substance or gas, otherwise aqueous. Okay, by using a short notations, for example, if it is solid, we use S, okay, and bracket. If it is a liquid, we use L, small l. If it is a gas, we use G. If it is aqueous nothing but any other solution which is present in water gives you aqueous. Then it is called as AQ. You can call it as AQ, aqueous. Okay, these are the short notations of main. Okay, solid, liquid, gases. Okay, here in this chemical equation, okay, see the compound, the chemical composition is there. It gives the more information. For the first time, it is a compound which contains iron and oxygen together there. These two are in a fixed composition called as Fe2O3. Okay, and aluminum individually. Like equations are there in a fixed composition. Okay, reactant side and product side. Whether those are liquids or solids or gases are and aqueous, or we need to know. If you know, then we can give the exact result. Understand? So these are the short notations of solid, liquid, gases and aqueous. Okay, in physical state, okay, especially physical means physical properties, right? Physical properties of the solid. For example, Fe2O3. Fe2O3, it is a solid or liquid or gas. If it is a solid, then you should write solid here, yes. Then we can know, okay, this compound is called solid. Iron oxide is a solid. Next, aluminium. Aluminium is a metal, right? Metal, already we know it is all are metals only, yes. Okay, when you apply heat them, okay, when you apply heat, then we will get iron, F. Iron is a solid or liquid? Solid only. Then we can write S. Next, followed by Al2O3. Al2O3 also is solid. Then in this reaction, all are solids only. So by mentioning these as a physical state, we can say all our solids are given solids only after the heating. Okay, so this is information about the physical state. Okay, if you mention all the solid, liquid, gases and aqueous, you can find out the exact statement. Okay, in this delta indicates applying heat. If you mention delta, it is called as applying heat. When you apply heat, automatically this gives you this kind of products. Okay, in case of physical state reactions, if you mention them, you can find out easily. Next, heat exchanges. Okay, in chemical change reactions and in chemical reactions, sometimes heat may evolve, heat may absorb. Okay, heat may evolve called as exothermic reactions, heat absorbs called as endothermic reactions. Okay, see here for example I tell you carbon when react with oxygen, carbon piece or carbon powder when burns in the presence of oxygen, Okay, it gives you carbon dioxide. There itself it gives you carbon dioxide, isn't it? When carbon dioxide releases, followed by there is a heat energy also evolves. Heat energy. Okay, this Q indicates energy. Heat energy indicates heat energy. When press Q, okay, gives you heat energy. Q indicates heat energy, plus Q indicates evolution of heat. Okay, evolution of heat in this case. Next, nitrogen reacts with oxygen. These two are gases only. Okay, this is carbon. It's a solid or liquid or gas? Solid only. Oxygen gas G, and here carbon dioxide gas. Okay, and energy released. Okay, notations are there. By using notations, you can find out. Next, nitrogen, it's a gas. Oxygen also a gas. Gives you NO as a gas only. Okay, minus Q nothing but absorption of heat. Q indicates heat energy, minus indicates absorption of heat. In this, absorbs heat energy absorbed. Heat energy absorbed in this. Okay, so using these notations you can identify. Next, zinc. Exothermic, endothermic completed. Now, gas evolved. What do you mean by gas? Gas evolved. In few reactions, gas may evolve. For example, zinc when react with hydrochloric acid, otherwise sulfuric acid. Okay, gives you one ZnSO4 as a precipitate followed by hydrogen gas is released. Understand? Here, zinc, a metal reacting with solution. Okay, reacting with one particular aqueous solution gives you ZnSO4, zinc sulfate as a solution, aqueous solution, and gives you gas also. Here zinc solid, H2SO4 aqueous, and zinc SO4 aqueous, and hydrogen gas is a gas. And also I can show with upward arrow. Upper arrow means it is releasing of heat from the equation. Okay, in this equation gas is released. Gas is released, that is hydrogen gas. Okay, it goes up. Then it is, we can show with this symbol upward arrow. Okay, so in this reaction gas is evolved. When gas is evolved, we can show with this symbol. Understand? Next, precipitate formation. Okay, precipitate nothing but there is a remain at the bottom. Okay, silver nitrate and NaCl. These two reacts each other and gives you AgCl and NaNO3. Okay, in this reaction, AgCl as a precipitate and precipitate in the bottom of the beaker. Okay, these two reactants reacting each other and giving you AgCl as a product followed by NaNO3. Okay, AgCl as a precipitate in this reaction. Okay, so in few reactions, gas may evolve, precipitate may evolve, heat may evolve, and the few reactions can continue in the presence of catalyst only. But in this reaction precipitate, we can show precipitate through downward arrow. Okay, gases means upward, precipitate means downward, because it is present at the bottom of the bowl only, right? So it is remain in the bottom only. Then we can show it is with downward arrow. Okay, AgNO3 NaCl gives you AgCl. Okay, is as a precipitate here. Next, catalyst. Catalyst nothing but to start one reaction we need some catalyst in few reactions only, not all the reactions. But catalyst role is it enhances the chemical reaction. Okay, it starts the reaction and wind up the reaction, but it won't participate in the chemical reaction. Nothing but at the end of the reaction it will remain or it goes out. Okay, it won't participate in the chemical reaction as a reactant, but it will start the reaction. It takes the initiation. Okay, it takes the initiation to start the reaction called as catalyst. But few reactions in the presence of catalyst only it is possible. If there is no catalyst, there is no formation of any chemical reaction. Example I tell you, carbon dioxide and water. When carbon dioxide, atmospheric carbon dioxide react with water, okay, in the presence of sunlight using chlorophyll, okay, and color, then it gives you good glucose and followed by oxygen gas is evolved. Okay, in the presence of photosynthesis, plants are preparing their food. Okay, by using atmospheric carbon dioxide and water. Okay, in the presence of catalyst. Nothing but sunlight and chlorophyll. Okay, these two are acting as a catalyst here. Then it gives you glucose, and followed by oxygen gas is evolving in this. Okay, upward arrow. Okay, so these are the catalysts. So by using these, we can know equation more informative. Okay, for example, I tell you once again, if it is evolves heat, then plus Q. It absorbs heat is minus Q. It is giving gas in the equation, upward arrow. If it is giving precipitate, then call as downward arrow. Okay, and catalyst is useful, then we can write upside or downside of the arrow marks. If you wanted to write a catalyst, we can write upside or downside of the forward arrow. Understand? If it is delta, means heating. Okay, you are applying heat to the reaction. Then when you apply heat to the reaction, we can call it as a delta. Okay, by using these notations, we can identify easily. Okay, followed by, if it is a solid, we can write S. If it is a liquid, we can write L. If it is a gas, we can write G. If it is aqueous, then you can write AQ. Okay, these are the short notations. Okay, if you know about these, we can know the reaction whether it is a gas or liquid, solid or aqueous. Okay, one solid reacting with gas and giving you some aqueous. Like we can identify. Okay, these are the short notations to interpret the chemical equation more informative. Okay, right. In this lesson, we discussed physical state, heat exchanges, and gas evolved, and precipitate, and catalyst the reactions. Okay, with the examples. Okay, if you have any doubts, comment. Thank you.